Well, good morning. If it is morning, in fact, otherwise, good day to you. And we're looking at a big array here. We're going to continue our work in math, thinking about how we can work with arrays to help us understand math problems. If we looked at this big array and someone says, how many are there? And if they presented it to us as a big math problem, we want you to know, you have an option with regard to that big array of breaking it into smaller parts and putting them together. And when we do that, we refer to a certain property, right? And here we go again, right? Another property or rule, right? And this time we call that distributive property, where we can take a big item, break it into two parts, and then put them together. It reminds me of this image that you've been familiar with since at least first grade, maybe even kindergarten, where we have a total of something, and if we break it into parts, we know that we can just put the parts together and get that total, right? This is true here. It turns out this is 10 rows. Let's see if that's true. We always have to. In math, you can always prove stuff, right? You don't have to believe anything. You can prove stuff. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we look at this, 10 rows, right? 10 groups of how many? Well, each one is 4, right? So 10 rows of 4. If we look at this as a 10 times 4 and we're not really sure, we think, that's really big. I want to work with smaller parts that I know. And you might say, well, what do I know? What smaller parts do I know? Do I know what 5 rows are? So if I take this thing and break it into 5 rows of 4, and then look at the other part, 1, 2, 3, 4, 5, get another 5 groups of 4, I know I can take these two parts and put them together. And that's the distributive property, as we call it. So now instead of 10 times 4, what we have is this array, which is 5 times 4, 5 rows of 4, and we have this one, which is 5 rows of 4. Well, if we want to put these together, these parts, we use these things called parentheses to kind of separate them. And as you might remember, the parentheses in math say, do me first, right? Do this part first. So before we do the addition and join them together, we'll do these parts first. As you remember from the last few lessons, 5 4s is 20, right? 5 4s is 20. There are the two parts, 20 and 20. And that's a mental operation. We do that in our head, and we know that's 4 10s or 40, right? So that is essentially the idea of today's math lesson, of this working with the distributive property. Will you say that one with me? Distributive property, where we kind of take the whole and distribute it into two parts and then put those parts together. That's one way to think of it, at least. The word distributive it's not a word we use on a daily basis when we think of math, but if we think of it part total, that works too. So let's think about how we might use this kind of thing in a problem-solving sense, right? Because why do we do math after all? We do math to solve problems. Who has problems? We all have problems, right? So who needs math? Well, we all need math. In this case, Lydia makes 10 pancakes. She tops each pancake with 4 blueberries. Oh my goodness, do you notice what I notice? How many blueberries does Lydia use in all? Are you thinking what I'm thinking? That 10 pancakes, what did we just do? What we just did is we worked with 10 groups of 4, and this very problem represents 10 pancakes, with each one with 4 blueberries, 10 groups of 4. You know what? This very solution is actually exactly what works here. Even the final question, how many blueberries does Lydia use, right? Lydia uses Right? We just solved that one. I don't think I want to solve this guy right in front of you, with you rather, again. Let's move to a different one, and we'll solve that. Now let's move to number 4. What a coincidence that was, huh? And that's the thing about math. Once you familiarize yourself with certain facts, you start seeing them repeat again and again and again. Let's do number 4 together here. So it looks like Stephen's got a challenge here. Stephen solves 7 times 3 using the break apart and distribute strategy. Show an example of what Stephen's work might look like. Well, to do that, let's see an array. You know, we've got to draw something. Let's draw his 7 times 3. As you know, when we say 7 times 3, there's other ways to say it. It could be 7 rows of 3 or 7 groups of 3. If I want to draw an array, let's do 7 rows of 3. Join me, please. 1 row. And what I mean by that is, can you count the rows with me? 2 rows of 3. 3. 4. 5 rows of 3. 6. 7 rows of 3. Now, we've got the array that matches Stephen's problem. It says, show an example. Sometimes I look back and reread because I don't remember. Show an example of what Stephen's work might look like. Oh, which means the way, like if you did this by yourself and I did it by myself, we might pick different ways depending on what we think would be simpler. So what fact do you know? Ask yourself that. When working with 3s, which fact do you know that like comes automatically, right? I'll tell you one that I think a lot of 3rd graders know automatically is 5 times 3. 5 rows of 3, which is the same as 3 5s. 5, 10, 15, right? We've known that one. So let's use that. And let's break it apart. 1 row, 2 rows, 3 rows, 4 rows, 5 rows. And breaking this apart, if I make this the 5 rows of 3 and label it, look at the other part. What is the other part? The other part is 2 rows of 3. So now let's make that big sentence, the one with parentheses, so that we can have the sentence, the expression, match the array. So we have the 5 times 3, 5 rows of 3, and we're going to join it with the other part, which is 2 times 3, and again we'll put those parentheses on, which really mean, hey, do me first before you start this, do the addition part, right? Do me first. Equals something. That's our whole, right? Let's solve it. 5 times 3, we pick this problem because that's the easy part for us. We know it's 15. Plus the 2 times 3, 2 3s is 6. Equals something, right? Join those together, and what do you get? 21. All right, which means ultimately, the whole reason we're doing this is to solve 7 times 3. 7 times 3 is 21, and we've got it. And that's an example of how we might use the break apart and distribute strategy. And that's exactly what you'll be doing in today's lesson. Good luck. Remember, make a drawing that matches it so that it makes sense to you, right? That's the most important part of math, and it's the most important part of today's lesson. Best wishes.